Hello AP Biology students, we're going to go over the 5th section of Unit 1. And in this section we're going to go over water. I feel like every science class I had in college had at least one section about water and its unique properties. So water, as you know, is H2O. It has 2 hydrogens and 1 oxygen atom. And this molecule is a polar molecule. Remember that polarity is just the unequal sharing of electrons between 2 atoms. The bonds between the hydrogen and the oxygen are going to be polar covalent bonds. The reason these are polar covalent bonds is because oxygen is more electronegative than hydrogen, so it's going to pull on the electrons more than the hydrogen will, which means the electrons are going to be in this region more than they're going to be in this region. This means since electrons are negative, we're going to have a negative charge here and 2 positive charges here. Since it has this negative and 2 positive charges, it becomes really good at dissolving other substances. And since it dissolves so many other things, we call it the universal solvent. This is because these charges, the positive and negative charges, do such a good job at dissolving and breaking down other substances. I always like to tell my students, like dissolves like. Polar molecules like to be dissolved by other polar molecules, and nonpolar molecules like to dissolve other nonpolar molecules. So as you can see here, we have NaCl, which is salt, being dissolved by water. Now, salt is composed of sodium and chloride, which have a positive and negative charge. What happens is the water molecules will be attracted based on their charges and rip those atoms from the crystalline structure. And water does this to a lot of other different polar molecules. As you can see in this animation, the water molecules are going to be attracted to the different charges of salt. The negative region of water, or the oxygen region, is going to be attracted to the sodium, or the positive atom. The positive region of water, or the hydrogens, are going to be attracted to the negative regions here, or the chloride atoms. So as you can see, water does a really good job at breaking down other molecules because of its charges. Water also forms these things called hydrogen bonds, which are attractions between the positive and negative ends of the atoms. And typically we represent these by having dotted lines between the water molecules. Now, they are very weak bonds. They are weaker than both the ionic and covalent bonds we talked about before. But since there are so many water molecules in even just a drop of water, they can create a lot of attraction between the different water molecules. We call attraction between water molecules cohesion, and attraction between water molecules and things that are not water molecules adhesion. And typically these adhesive properties or adhesive attractions are going to be between water and other polar molecules. Now, like I said before, even though hydrogen bonds are weak, since there are so many water molecules in even a small amount of water, there is a high attraction between all those water molecules, and they create something called surface tension. Again, this is just the attraction between the water molecules and themselves, and how they can repel other molecules that try to make their way into the water. I'm sure you've all tested water and the surface tension, but basically it's just how the water repels and pushes away objects that are placed on it. Next, we're going to talk about something called the density of water. Remember that solid water is just ice. And remember that solid water, or ice, floats on liquid water. The reason that ice floats on water is because it's less dense. If we look at our 2 types of water here, you can see ice and liquid water. Ice has less molecules per area than the liquid water does. So what that means is ice is less dense than the liquid water. And I know it's like, okay, yeah, we know that ice floats. But this is actually kind of rare. Usually the solid form of a liquid form usually sinks in the liquid form. It's because usually it's more dense, but in this case, what happens is the water molecules are going to spread out whenever water freezes into ice. And as water pushes the other water molecules away, when it forms this crystalline structure, it's going to become less dense. And again, why do we care about this? Why do we care about ice floating on water? Well, if solid water didn't float, we couldn't survive. I found this image last year and I had to manipulate it a little bit, but I think it does a good job of showing why we need ice to float. Take a look at this top image where the ice is going to form as water gets colder and float to the top. What happens is this ice at the top will actually insulate the water down here at the bottom, keeping it a little bit warmer. This allows life to still survive even though it's at a cold temperature. If ice didn't float, if ice sank, what would happen is the ice would form at the bottom and freeze from the bottom up, killing all the life in it. And since life evolved from the water or the oceans, we need this ice to float in order for life to be here on Earth. If ice didn't float, we wouldn't have life. The last thing we're going to talk about is something called high heat capacity. Water holds on to heat very well. However, it takes water a lot longer to absorb that heat than other molecules. I always like to make the comparison of the sand in the water at the beach. When you're walking out to the water, the sand is very hot because it warms up very quickly. So typically you run from the sand to the water because the water is cooler. Even though the sun is heating both the sand and the water, it's taking the water a lot longer to heat up than it is the sand. Here's an example of that high heat capacity, where this flame is melting the plastic, but it's not able to melt the plastic and the water. That's because it takes a lot more energy, a lot more heat to heat up the water. So what that water is doing is it's absorbing all of that heat. This is again because water has such a high heat capacity or an absorption of heat. Also, don't let anyone fool you when they talk about dihydrogen monoxide. That's just another name for water.